All right, so I'm gonna finish up a little bit in 2.4 at the end, since I wasn't able to get on 9 Friday. And then we'll knock out 9.1. So then y'all try the ones at the end of 2.4. It wasn't too bad. All right, y'all, so they're giving me two functions. They're giving me f of x is going to be x squared, and g of x is 4x minus 7. So on these problems, they want me to find the domain of the sum difference and product. And that's all they want me to do is find domains of these, okay? So I'm going to play with the sum first. So f plus g of x would equal my f of x plus my g of x. So they gave me f of x was x squared, and then g of x was 4x minus 7. Now you can stop there, or you can actually combine everything you can and then try to find that domain. But I'm looking at both my functions and I'm wanting to see if any of them have a. What would you like to do? And by restrictions, I mean Gaussian fractions. So there's no fractions on my f of x. There's no fractions on my g of x. So since I don't have any fractions, there's no issues I'm worried about on this domain. So this domain would be x such that x is a real number. Right, so let's look at the difference. That'll be f minus g of x. So that'll equal our f minus our g. So once again, that is an x squared. And then what, a 4x minus 7. Same situation, right? And you'll notice that on these problems, on the domain, whatever you're getting for the adding, you're pretty much going to get the same thing for the subtraction. So I don't have any fractions to worry about that are making undefined. So once again, it'll be x such that x is a real number. And then I have what the product, which would just be these being multiplied. So f times g of x, we got f of x times our g of x. So x squared times 4x minus 7. Well, once again, do I see any fractions? So nothing to worry about on that as far as fractions. So once again, my domain will be x such that X is a real number. Right? Ooh, let me catch up with y'all.
Tommy, for you. Walker, Taylor,
We got about 2 more to go, right? Now, they didn't ask it on this one, but had I worried about division, then I wouldn't have to worry about these domains too. If I was doing division, this would have been on the bottom, which would have gave me some issues. Okay? All right, so let me do one that ain't going to be for all real numbers. All right, y'all. So f of x on this one is going to be 1 over x minus 3. G of x is going to equal 9x to the third. So once again, I'm going to find a domain of the sum difference and product. But you'll notice they'll be really similar. Okay. So if I was going to add these, f plus g of x, I'll take my f of x plus my g of x. So f of x was 1 over x minus 3. And what I have for g of x, 9x to the third. So if I'm going in, chugging in my numbers for my x's, I'm a little worried about this one because I do have a fraction. And the only one that's worrying me is that right there. Now the 9x to the third, not worried about it. Any number I can get into that. I can multiply, count itself 3 times and all that fun stuff. But we are worried about the first fraction. So to find any numbers that might make it undefined, all I did was take that bottom and we said it could not equal 0, right? So we solved that by adding 3 to both sides. So that tells us what? X cannot equal 3. So my domain will be x such that x is a real number and x cannot equal 3. And just remember, when you're doing a domain, all you're looking for are the numbers that cannot be part of that domain. We kick them out, and then that means any other number I can plug in for my zeros and get a real number out of that, okay? All right, question on the adding. So let's see, let's do a little subtraction. So that would be 1 over x minus 3 minus 9x to the third. So it looks the same other than the operation is not a plus this time. But I'm still worried about the domain on it, right? And we know it's what, this fraction right here. So if I solve that bottom, I will still get the 3 out of that. So this domain is going to match my addition, right? So x such that x is real and x is not equal to 3. All right, so we got the sum, the difference, and now we're gonna do the product. So that'd be F times G of X equal to F times the G. So I got 1 over X minus 3, and then 9X to the third. Same situation, right? You're still worried about the first term, which is the 1 over X minus 3. So my domain is going to be X. So if X is a real number, and X cannot equal 3. Okay. So let me do the one that's only different, right? Oh, hello. Last name. About the coolest y'all been here, right? All right, so here we go. They're giving us f of x, 4x minus 5, g of x, 5x minus 35. They want me to find the domain of f divided by g of x. Well, that's a little different because I just got division here. So I'm going to set it up. F divided by g of x will equal my f, which was 4x minus 5, divided by my g, which is 5x minus 35. So we worried about a domain on this one. Yes, because we definitely got a fraction there, okay? Now, we don't care about the top of this fraction. We're only worried about the bottom. So remember, to find those numbers, we're going to take 5x minus 35 and set it not equal to 0. I'm going to what, add my 35 over? Five x cannot equal 35, because if 5x equals 35, that'd be a big 0. But we want to know what that x is actually going to equal, right? I'm going to come in and divide by the 5. So the funny x cannot equal 7. And 7 is the only number I can put into this that'll make this undefined, right? So my domain will be x such that x is a real number. And x, we said, could not equal 7. Okay, so remember in this section, when you're looking at a domain, you're just looking for any numbers that makes it undefined. And you're only worried about fractions in this whole section, okay? Now remember, later on in life, we got to worry about domains when we start messing with the radicals, like the square roots and stuff. All right, so we're going to move into 9-1. So questions on that? We'll get into better math, I guess. Won't be all this domain stuff. So this is 9-1. So you notice we sort of skip around a little bit, but these sort of went with what we was doing, so it's all together. These are called the composition of functions. So let me write some symbolism up here for this, and we'll see if y'all have ever seen this. Y'all ever seen this notation F of G of X? That little zero in the middle is like a degree symbol, sort of. It's not an O or a zero, it's like that little degree symbol. We call this the composition operator. But we call this fogging line, I guess. But F composed G of X really equals F of G of X. So basically what you do on these problems is you work your G of X part first. Once you got that G of X figured out, you put it into all the X's of the F. It's like you're almost putting the whole function into those X's now, okay? Now this goes the other way, and we might have a G of F of X. So same thing, this one would take the F of X first, figure out the F of X, and then it would put it into the G. So y'all are playing with these? Oh, so you're gonna be the one that knows them, right?
I need to refresh it.
All right, so I'm gonna go slow through this first one to show y'all everything that's happening on these, okay? But this is the one time that I don't go left to right. I'll put my X into my G, get that answer, then it's gonna go into that F. And if it's G of F, I'm gonna get the X, put it into the F, and then take that answer, put it into the G, okay? So it's almost like you're doing innermost parentheses, working your way out on them, okay? So I'm going to start out, they're going to give me numbers for the X's, and then about halfway through, they're just going to give me variables, okay? So y'all, this one says let F of X equal negative 2X minus 1. G of X is going to equal X squared plus 2. They want us to find F of G of a negative 1. So, dog, this is just like F of G of negative 1. So you write it like that, okay? Which means I got to figure out G of negative 1 first. Once I find G of negative 1, I'm going to put that answer into my F equation and find that. So first thing we're going to do is find G of negative 1. So to find G of negative 1, I'm going to take that G equation, and in place of X axis, I'm going to put negative 1. All right, there we go. G of negative 1 will equal negative 1 squared plus 2. Y'all, will warn you, if you do that on your calculator, when you put that negative 1 in there and square it, you better put it in parentheses. Because remember, a negative times a negative is going to make that a positive. But if you don't put that negative in parentheses and you do negative 1 squared, it's going to give you negative 1. Since that negative's not in parentheses, it's not going to square it for you, okay? So -1 squared is a +1. And then 1 plus 2 gives me 3. So g of -1 equals 3. So now this 3, it goes into my f of x, which means the second thing I'm going to find, is what f of 3. Does it make sense? I found a -1, put it into my g, that gave me a 3. So that means now we're finding f of 3 like you said. F of 3 will equal to f equation, -2 times my x minus 1. And we said in place of the x, we're going to put that 3, okay? All right, so let's see, we got to multiply first. So -2 and 3 will give you -6 minus 1. And that's what, a -7. So f composed g of a -1 in this case was a -7. So those are a little wild, ain't they? I guess this would be stuff like your banks would do. They figured out your interest before they can figure out your monthly statements or something. So they need one formula in order to find another one. Scientists do it a lot. You might have equations for work that are what, force times distance, but another formula might give you the force. So you find the force, then you put it into the other equation to find the work or something. Okay. All right, this one has f of x equals 2x plus 2 g of x is a x squared minus 3x minus 4. This time we're going to find g composed f of a 7. So writing this one out, it would be g of f of 7. So this time we're not starting with the g, right? We're going to be starting with the f, which looks like the first thing I'm going to do is find f of 7. So y'all see, that's what I'm saying. We're sort of working right to left on these. I put the 7 into the f, and then that whole answer is going into the g, okay? All right, so f of 7 is going to equal 2 times x, which is 7, plus 2. All right, so once again, we'll multiply before I add. So 2 times 7 is what? 14 plus 2, which will give us a 16. So now this 16, it goes into g of x. Trying to find the f, put in the g. Here I found the g to put in the f. So watch out, am I going f of g or am I going g of f on those, okay? All right, so that means I'm going to be finding a g of a 16. That's going to be fun because g got some squares in it, don't it? All right, here we go. G of 16 is going to equal x squared, which is 16 squared, minus 3x, which is 3 times 16, minus 4. So you got an x squared minus 3x. Both of them x's have to be replaced with the 16. Oh, yeah. We in Arkansas, that's a good one. 16 times 16. Oh, that's pretty good. You from Little Rock? Okay. I know when I was in Little Rock, we stopped at 12 times 12. That's why I was asking. Right? Everybody know what 12 times 12 is. What's 13 times 13? I got you.
I don't do odd numbers.
169.
Huh?
169.
There you go. She must went to
I
practice
was
school.
just gonna say, she can go there.
Now this ain't bad. 3 times 16, that's what, 48? And then minus my 4. All right, so let me see. I know this end is what, a negative 52. From 56, when I get a 204. And these are, okay. I don't think these are that bad, y'all. But when they quit giving us numbers, they get a little trickier. But this one has numbers. So here, f of x equals 5x plus 3. G of x is going to equal x to the third. We're going to find f of g of negative 3. All right, so if we're writing this out, I have f of g negative 3. So first I'm going to do g, I heard it somewhere. And that's what, a g of a negative 3. Oh, but g is x to the third, so that's basically going to be a negative 3 to the third power. So I know a negative to an odd exponent will stay negative, so we just got to figure out 3 times 3 times 3. 27. So I'm going to get what, a negative 27 for that, okay? All right, what's the next one? Oh, I was trying to figure out. I called you the other day. All right, you good, you good.
I'm sorry, I hurt my spine at work.
All right. Well, we're maxed out now. I'm going to lock her down. All right, so remember now, since I know my g of negative 3 is negative 27, this is now going into my f of x. So I'm going to be finding a f of negative 27. So that means I'm going to take that f equation and throw in that negative 27 so that I get a 5 times negative 27 plus 3. All right, so let's multiply. We know that's a negative something, right? What's that, negative 135?
I got 132.
Oh, but you done added your 3 up there.
Oh, sorry.
So let me throw my 3 down there. Now guess what I'm going to get? Negative 135 plus 3. Negative 132. Okay. So notice when I throw a number in there, you can work that number in the first equation, take that answer, put it into your second, okay? All right. Oh, don't get me the line. 9.1 would be like 4. So that one. And I'm doing this stuff right here.
Okay.
All right, y'all, so this one wants a little bit more work. So we're given f of x is going to equal x plus 15. G of x will equal x minus 15. We're going to find f of g of x, g of f of x, and the domain of each. We can almost say this is almost like 4 problems in one, okay? So I'll find my f of g, my g of f, and then I'm gonna look at those domains, okay? So f of g of x is like a f of g of x, right? So the first thing I gotta do is find g of x. Notice, I don't have a number to put in for the x this time, do I? So g of x, they gave me. That was what, an x minus 15. Couldn't do nothing to it because they didn't give me no numbers. But guess what? Since g of x equals x minus 15, this x minus 15 now goes into my f of x. So I'm not just putting a number into my f this time, I'm putting the whole function into my f of x. Which means we're going to be finding f of an x minus 15. Right, since g was x minus 15, it's going into the f now, okay? So where's f? F is x plus 15. In place of this x, I'm going to put x minus 15. And then at the end is a plus 15. So remember, this part right here, the x minus 15 was my g going into my f, okay? So the only question is, can we simplify that? So what y'all do with that? Because you got like terms right here. So that ends up being just a x. Okay, so a little bit more work when you don't have a single number going in, but it's still not too bad, okay? All right, now we're going to find g of f of x. That's like a g of f of x. So the first thing we want to find is the f of x. You know, once again, they didn't give me a number to put in there, so I know that f of x has to be x plus 15. There you go. So can we do anything to that x plus 15?
No.
No. So remember, this x plus 15 now goes into our g of x. That whole thing going in there for g of x, which means I'm going to find the g of x plus 15. So g started out x minus 15. In place of that x, I'm going to put the x plus 15. So I get x plus 15. And then at the end, it's still a minus 15. There you go. Well, I guess you can simplify that, right? And I end up with a X.
So you don't want us to put one, you want us to put X.
You want him?
You don't want us to put one, you want us to put X.
You can try one on MathLab. But remember, if you see a 1 by X, they know you can multiply that. And 1 times X is just an X. Now, any other number like a 2 times X would still be a 2X. But watch out, sometimes in MathLab, if you put a 1 in there and it's right, it might tell you, although you got the right answer, you're not in the right form. So if you see something like that, then I would do away with the 1, but I think it'll take those. Now, it's also picky about exponents of 1 too, right?
Yeah.
Because anything to the first power is itself. And then it don't like 1s on the bottom. So if you got a fraction with the 1 on the bottom, because it knows you can go on and divide that out and make that the whole number, okay? So sort of picky on the 1s, you just gotta see if it tells you when you're writing it in there, if it's in the right form or something like that. Alrighty, so same thing we did here. I can say all these won't equal to X, okay? There it is. Well, this one, they turned it up a little bit. So I got an f of X equals X plus 1.
What is that for that?
This will be like y'all's number 5.
I don't think you ever finished the domain.
Oh, hell, the domain, there you go. So leave that there. Well, let me erase this thing. That's the problem right there, ain't it? All right, so the domain, and I'll do the f of g first. So here was f of g of x. I started out with a g of x, x minus 15. Any restrictions? Because there's no fractions there, right? Then when you plugged it into your f, x minus 15 plus 15. Any restrictions? No, because we plugged that into our x there, so no restrictions. So this domain was x such that x is a real number. And then how about the domain of g of f of x? So my g was here. I started out with f of x, which was x plus 15, no restrictions because there's no fractions. And then once we plug that into our g, we got x plus 15 minus 15. Still no restrictions because there's no fractions. So my domain for g of f is going to be the same thing. X such that x is a real number. All righty. So actually there is a radical in this one, okay? So let me show you what to do with a radical. So y'all, f of x is going to be 6x plus 1. G of x is going to be the square root of x. So when I look at the domain on the square root, I'll show you what that has to be, okay? How you would sort of do that one. But first, let me find this f of g of x. So that's just like the f of g of x we said. So the first thing I'm going to do is find g of x. Remember, I don't have a number I'm putting in there, so g of x is just going to be a square root of x. Cannot do nothing to that, so that square root of x will now go into the f. So this goes into f of x now. So you notice basically on these problems, when we don't give you a number, you're taking the second function and throwing it into the x's on the first one, okay? That means I'm going to be finding f of a square root of x. Remember, I'm just putting that here because that's telling me what I'm putting in for those x's, right? So f is a 6 times this x, which was the square root of x, plus 1. And you'll notice that when you do these, the second function always looks like the first function, other than those x's, okay? Hey, can you do anything to that? No. 6 times square root of x is going to be a 6 square root of x, and you cannot add a radical two-way number, so cannot go no further. Let's find g of f of x. So this one will be like our g of f of x. So first thing we'll find is the f of x. So it's the f of x was what? 6x plus 1. Can y'all do anything to that? No. So this whole thing now goes into my g of x. So I'm going to be finding what g of a 6x plus 1. So g was the square root of x. So this is now going to be a square root of 6x plus 1. There you go. So question, can you do anything with that? No? So that'll be the final answer.
So this is that.
Hmm.
So it'll be just the D.
So you'll just throw this into your math lab and be done with it. Okay. They should already have the G of F stuff and the F of G stuff sitting there, so you just throw in that final answer and be done. Now here comes the domain. And I'll do the domain of F of G first. So I did F of G first, but bam, I hit a radical right off the bat. So the thing about radicals, when you're looking at domains for the radicals, can you take the square root of a positive number like 1? Square root of 1 is 1. Square root of 4. Now everything in between is going to be like big ugly decimals. But the idea is we can take the square roots of all those nice positive numbers. Can I take square root of 0? Square root of 0 is 0. The thing I cannot do, can I take the square root of a negative 1? Oh no, you're trying to take the square root of negative 1 on them calculators, it's going to definitely give you an error because those are non-real answers. Because there's no way like signs can equal a negative, okay? So whenever you did square roots of stuff like negative 1, you got answers like 1i. Square root of negative 4, you got stuff like 2i. Those are imaginary numbers. They're not real numbers, okay? So when you're dealing with a radical, that, since we got a square root of x, we know that that x, this x right here, has to be greater than or equal to, what's the smallest number I can take the square root of? 0. So in a radical, it can be 0 or any number positive. You cannot take square roots of negatives. So this one tells me x has to be greater than or equal to 0. So in this function, I could not put a negative number 1 into it. Because once I put a negative number into it, it becomes imaginary.
Is this where you like, you have to switch the sign and stuff?
Say again now?
Is this one we have to like switch the sign and stuff?
Oh, no, not now. But you're getting there in a little bit later in life. So now, where'd my second part go? I still got the single radical, right? And it's still got a single x under it, which means that the x still has to be greater than or equal to 0. So when we write this, we're going to come down x such that x is a real number and x has to be greater than or equal to 0. So if you're wondering why the other day when I was doing these, they had these greater than and less than, getting you ready, I guess, for the radicals, okay? So now we got what, g of f. So the domain of g of f of x. So I'm going to start with f of x, which is, I had what, a 6x plus 1. Any restrictions on that part? No, because I don't have a fraction or a radical yet, okay? So no restrictions on the f of x, but what about the g of f? So g of f of x, we said equals what? Square root of?
6x plus 1.
So any restrictions? Oh, watch out, because guess what I got sitting there? I got that big radical sitting there. Now, although this one ain't an x, I do know that this 6x plus 1 has to be greater than or equal to 0. So fractions, we take the bottom and we set them not equal to 0 to solve them. Radicals, they got to be greater than or equal to 0. So y'all, we can solve that one in a couple of steps. So to solve this, I'm going to subtract my 1. So 6x has to be greater than the negative 1. Because if this part equals negative 1, that gives me my 0. But it can equal that, right? All right, last step, let's divide this. So x has to be greater than or equal to a negative 1/6. So if you put a negative 1/6 here, you get negative 1, and then negative 1 plus 1 is 0, so we're good. Anything else to the negative side is going to kill us, okay? Now, remember one thing. What if I had this? And I divided this by a negative 6. What would y'all do to that? Well, you bring down that x for sure. This is where I will take that little inequality and split it. Only if I divide by negative. So that this would become a less than instead of a greater than. So y'all watch for that kind of stuff. If you're solving these inequalities and you got negative values on your x, when you divide by those negative numbers, you do have to flip it, okay? Remember, I didn't have to do that on this, I was just showing you. Okay? All righty, so about that time, y'all. So that takes care of that. So we come back, we knock out 9.2. And then next week we'll knock out all the 3 point whatever. I think we got a 3.5, 3.6, and 3.7. Those will let you ride right into them, okay? Main thing by tonight, you have to have your course agreement quizzes done. And they're like little quizzes in Blackboard. Oh, okay.
I was thinking, where's I'm plugging everything in right and it's not right.
All right, y'all, any questions online?
Yeah.
No, I wrote everything down.
Again?
I said, no, I was writing everything down, going along with you.
Okay, that'll work.
Okay.
All right, so I'm gonna save your videos.